In Module 6, Lesson 2, we're going to look at displaying a data distribution in a dot plot. So example 1 uses heart rate to collect the data. Mia, who's a 6th grader at Roosevelt Middle School, was thinking about joining the middle school track team. She read that Olympic athletes have lower resting heart rates than most people. She wondered about her own heart rate and how it would compare to other students. Mia was interested in investigating the statistical question, what are the heart rates of the students in my 6th grade class? Heart rates are expressed as BPM, or beats per minute. Mia knew her resting heart rate was 80 beats per minute. She asked her teacher if she could collect the heart rates of the other students in her class. With her teacher's help, the other 6th graders in her class found their heart rates and reported them to Mia. So the following list are the heart rates for the other 22 students in Mia's class. To learn about the heart rates, a good place to start is to make a graph of the data. There are several different graphs that could be used, including the 3 types of graphs that you will learn in this module, which are dot plots, histograms, and box plots. In this lesson, you're going to learn about dot plots. Mia noticed that there were many different heart rates. She decided to make a dot plot to show the different heart rates. She drew a number line and started numbering from 78 to 92. 78 was the lowest heart rate. No, 78 is a little beyond the a little before the lowest heart rate, and 92 is a little above the highest heart rate. She then placed a dot above the number on the number line for each heart rate. If there was already a dot above a number, she added another dot above the one already there. She continued until she had added 1 dot for each heart rate. And here is Mia's dot plot. Notice she didn't put every number as a marking on the number line. She counted by 2s. So 79 was halfway between 78 and 80. She simply went through the data, and when she found 89, she came over to 89, put a dot. 87, put a dot. 85, put a dot. 84, 90, 79, 83, 85, and that's the second time we have an 85, so she added another one, and so on. Looking at the dot plot, what was the heart rate for the student with the lowest heart rate? Well, that was 79, and we can see on the dot plot the answers to these questions very easily. What was the heart rate for the student with the highest heart rate? That was 90. So we have 79 for the first, and then 90. How many students had a heart rate greater than 86? To go back to our graph, remember it says greater than 86, so it would not include 86. And we have 1, 2, 3, 4, 5 dots, which means 5 students had a heart rate greater than 86. What fraction of the students had a heart rate less than 82? So again, we're looking at the numbers that are less than 82. That does not include 82. And there are 2, and we're writing a fraction, so that means we need 2 out of the total number of students. 1, we'll just count up all the dots to find the total number of students. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So 2 out of 22, or simplified, 1/11, had a heart rate less than 82. What is the most common heart rate? Well, that would be 83. It has the most dots on our dot plot. What heart rate describes the center of the data? So we would be looking then at the exact center and it should be somewhere around 85. We could count to get there. Some of you may have chosen 84. For this particular exercise, either one is fine. What heart rates are the most unusual heart rates? Those would be the ones that happen the most rarely and are furthest from the center. So we would do 79 and 90 because they are so much further away from the center than the others. If me as teacher asked what the typical heart rate for 6th graders is, what would you tell her? Well, most students had a heart rate between 82 and 86. And the most common is 83. Then we needed to add a dot for Mia's heart rate. And remember, Mia's heart rate was 80. 80 beats per minute. So when we look at the dot, we would add the dot right here. And Mia's heart rate at 80 is lower than most of her classmates. Mia's class collected data to answer several other questions about her class. After they collected the data, they drew dot plots of their findings. Following is a dot plot showing the data collected to answer the question, how many textbooks are in the desks of 6th graders? When the students thought about this question, many said that they all had about the same number of books in their desk, since they all take the same subjects in school. The class noticed that the graph was not very spread out, since there were only 4 different answers that students gave, with most of the students answering that they had 6 books in their desk. Another student wanted to ask the question, how tall are the 6th graders in our class? When students thought about this question, they thought that the heights would be spread out, since there were some shorter students and some very tall students in class. So here's a dot plot of this student's heights. Notice how much more spread out this data is than the data for the textbooks. Both are statistical questions, but the answers are closer together for one than the other. Below are 4 statistical questions and 4 different dot plots of data collected to answer these questions. We're going to match the statistical question with the appropriate dot plot and explain why we chose that. The first statistical question, what are the ages of 4th graders in our school? We have dot plot A that has 9 and 10, which seems reasonable. Dot plot B ranges from 0 to 8, with most of the data falling at 1 and 2, and that doesn't seem very reasonable. Dot plot C ranges from 1 to 3, with most of the data at 1. That doesn't make any sense either. And dot plot D ranges from 58 to 73, which again doesn't make any sense whatsoever. So dot plot A because most students in 4th grade are 9 or 10 years old. Question 12. What are the heights of the players on the 8th grade boys basketball team? 8th grade boys basketball. So when we look back down here, dot plot B, 0 to 8. No, they're definitely not that tall. 1 to 3, no. Dot plot D is the only one that makes any sense whatsoever. Those are reasonable heights for 8th grade boys. Question 13. How many hours do 6th graders in our class watch TV on a school night? We have ranging 0 to 8, with most being 1 or 2. And then we have 1, 2, and 3, with most of the data being 1. In looking at the other question that's left, which is how many different languages do students in our class speak, it seems very unreasonable that students would be speaking 8 languages. So, question 13, how many hours do 6th graders in our class watch TV, seems more reasonable for dot plot B. Students could be going home and watching TV all night. And question 14, of course, was our dot plot C. It isn't reasonable for students to be speaking 8 different languages. So remember, numerical data is collected to answer a statistical question and can be put in a dot plot. The dot plot is one where the data value is represented by a dot over a number line. And the number of dots over the number line at a particular value tells how many of the data points have that value. A dot plot can help you find the smallest and largest values, see how spread out the data are, and see where the center of the data is.